So we spent a lot of this week talking about the mechanical properties of bones and how they respond to mechanical loading. Next week, we're going to be looking at cartilage, ligaments, tendons, and muscle. But before we do that next week, I do want to give a little bit of background on friction for those of you who are not familiar with it, or not familiar with like the mathematical treatment of it. The reason we'll need it is because to understand the role of cartilage and the role of synovial fluid in joints, meaning why do you have anything here? Why not just have a bone sitting on top of another bone? Why have cartilage to begin with? We'll need to have an understanding of what friction is and how it works. So you won't need the physics class, a box is sitting on a ramp and how steep can the ramp be before it rolls down. All you need is an intuitive understanding of the equation that governs the force of friction. So we don't see too many equations in this class, but I'm going to write out one right now. So the equation we care about is that the force of friction, this F subscript friction, is equal to something called the normal force multiplied by this thing we call the coefficient of friction. Usually we denote with a mu. And this is just some number, and that has to do with the intrinsic properties of the two surfaces that are sitting on top of each other, like, say, a cardboard box sitting on the ground. There's some coefficient of friction that tells you how much force is going to be generated between the ground and the box in this direction if I try to push the box in this direction. So that has to do with the properties of the two surfaces, and it also has to do with properties like lubrication. So you might think if you grease up the floor with dish soap, it'd be easier to push the box, and it would be easier because the coefficient of friction would go down. So the normal force in physics class, you would usually think about this as like the weight of the object, or the weight of the object plus the weight of whatever's like pushing on it. But that is essentially, you can think of that as the I'm going to write a term that maybe you don't see in physics class. I'm going to say contact force. And the reason I'm writing that is that's like the equal and opposite forces that you would have in a joint. So the tibia here pushing up into the femur. The reason the tibia can't just like smash through it is because the femur pushes back just the same amount. So those forces, this force pushing on this way induces a reaction force like this. That force is the normal force. Now you can think about it as being this or being this. It doesn't actually matter because they're always going to be equal and opposite. So in the context of joints and their ability to move freely or not, that normal force we can think about as the joint contact force. And to reiterate something I've mentioned twice already for this week, one way to increase this, obviously, is just to have a higher body weight. But another way is to have your muscles contracting. So imagine one of, say, the hamstring muscles coming off like this and creating a force like that. That is going to, and maybe the other hamstring comes off like this, that's going to induce a greater contact force here, which would mean there'd be more friction, even if the coefficient of friction stays the same. So I won't have any like math problems on this, certainly on the exam. I might sneak one in on the problem set for this, but it will not be a difficult one. The only thing you'll need to understand is the intuitive relationship between both the normal force and friction and the coefficient of friction and the friction force. And we'll see that conditions like arthritis, for example, or having a joint replacement are going to modify that coefficient of friction, and so they're going to modify the degree to which you can freely move your joints. So I just wanted to give a primer on friction for this week. For those of you who have not seen it, we will see it come up next week in the material on cartilage and joints.